In this video, let's see how we can create a signer list and also disable the master key so that there is only one way to authorize the transaction, which is using the signer list. Now let's get to the XRP faucet and create our master account. So this account is an active account which got activated at this ledger sequence number and also has 1000 XRP on test network. Let's copy the secret key of this account because we need to sign the transaction to set the signer list. I'll create a constant called secret and also derive the account, that is master account, using derive method. Now let's check the account information of this master account. We know that this is a brand new account and it has all the default things, but still let's check it. Command is account info and the R address is present inside address field of the master account. Let's just output the information and check couple of fields. So as we already know, it has a balance of 1000 XRP, no flags set, and make sure to check this, the owner count is 0 because once we set the signer list, this owner count will be incremented by 1. Now let's check another command called account_objects, which lists all the objects on that account. Again, we know that there are no objects on this account because this is a brand new account. As you can see, this array is empty. The account's object doesn't have any objects as of now. But once we create the signer list, you can see signer list object in it. Okay, let's create couple of XRPL accounts and set them as signers for this master account. So this account was activated at this ledger sequence number with 1000 XRP balance in it. I'll use this R address because that's all we need to set this as one of the signers. We don't need its secret key. So this is the R address. But still I'll copy the secret key and have it in the comments so that we can use it while making a multi-sign transaction, probably in our next video. So let's just have it in comment here. I'll call it secret 1 as this is associated with account 1. So similarly, let me create another account, which is also an activated account because we are creating it using XRP faucet, which activates the account by default by sending it 1000 XRP. Again, it got activated at this ledger sequence number. I'll copy the R address of this account and then also copy its secret and have it ready in comment, just so that we will need it when we are making a multi-sign transaction. I'll call it secret 2 because it's associated with account 2. Now let's do something different now. Let's generate an account, mathematically generate an account which is not even active on XRP ledger and assign it to account 3. Let me comment this out. Account 3, let me generate a family seed. Let me keep it simple like this. Okay, again, let me copy the R address and save it in the constant account 3. And also let me copy the secret of this mathematically generated account. We will need this while making multi-sign transaction again. Okay. This is to prove that these accounts in the signer list can be activated or even not activated accounts, doesn't matter. So let me remove this and Let me show this to you. This account 3 is not an activated account. You can just check that using account info command. Everything. No, it's account info. I think we have accounts object in the command. Yeah, it's account underscore info. Let me run this. As you can see, this account is not found on the ledger because it is not activated on the ledger. But then if you check for other two accounts, it is activated accounts. So you have balance, ledger entry type, owner count, everything an active account holds. So this is activated account, this is activated account, account 3 is just mathematically generated account and not active on XRP ledger. Now let's create the signer list. At first, let's fetch the sequence number from the master account. I'll fetch account underscore data field directly. We need sequence number of this master account, and the R address is present inside the address field of this master account. We don't need this. Let me remove this. Let me get to the documentation part. References, transaction type. Scroll all the way down to get this signer list set. Add, remove or modify an account's multi-signing list. So let's just read the definition. The signer list set transaction creates, replaces or removes a list of signers that can be used to multi-signer transaction. Create, replace and remove a list. Okay. So let's look at the payload information. This is not relevant. Flags. The transaction type is signer list set. This is the account for which we are setting the signer list. And the fee is normal, just fetch it from the ledger. There is no special fee because it is not a multi-sign transaction. This is a regular transaction to set the signer list, okay? So the fee is normal, just fetch it from the ledger. We already discussed about SignerQuoram in our previous video, please watch it. It has to be greater than 0 and less than the sum of all the signer weights. And this signer entries field, it cannot be empty. It must have at least one signer and no more than 8 signers. But with expanded signer list amendment, you can have up to 32 signers and a data field for each individual signer. We'll explain that once the amendment is voted in and is enabled on the main chain. So let's check multi-signing, the benefits of having a multi-sign account. So let's read this. A signer weight. You can assign a weight to each signer in the signer list. This is important. The weight represents the relative authority of the signer to other signers on the list. I'll repeat. The weight represents the relative authority of the signer to other signers on the list. The higher the value, the more authorization authority. So that is signer weight. So if you have not watched our previous video, I would highly recommend you to just go back and watch that multi-signing concept video, which will be very helpful. So let me open up the code editor and write the actual payload. So the transaction type is signer list set. And the account to which we are setting this signer list is our master account. And we only need its R address here in this field, which is present inside the field address. Always fetch the fee information from the ledger directly. Here I'm hard coding it to 10 drops, which is sufficient for test network. Fetch the sequence number of the master account, which is present in the sequence field under account underscore data. Now SignerQuoram. We have already discussed this. I'll use the same values. You can use anything from above 0 to anything. I'll just use SignerQuoram of 3 and then signer entries. This is an array of objects as I said, you should not leave it empty. It should at least have one signer in it. Let's just leave it empty and just try to execute it. It will throw error. Let's check that. Let me sign this payload using the master account. This account, the private key information is present inside this constant. Let me pass this signed transaction value with this command, that is the submit command, with tx_blob field. That's it. Let me output the result onto the console window. It should throw error because signer entries is empty, and by default it should have at least one signer in this list. Let's check that. So as you can see, it output an error, that is malformed transaction. So let's make an entry here. So this is an object. Inside that, this is plural form, that is signer entries, and here individual object should be signer entry, which is the singular form, which is also an object which takes two fields as of now, that is the R address, which we have in these constants, that is account 1, account 2 and account 3. I'll have account 1 here, and then the signer weight. And remember, you can't have a signer weight of 0, it should be positive. Okay, now let me just copy paste the same thing 2 more times and change the account information from account 1 to account 2 and 3. Okay, now let's experiment. I'll have this signer weight set to 0. It must be equal to or greater than this SignerQuoram, right? Let me set this to 0. First of all, you can't have signer weight to 0. It should be positive. And then second thing is, it is not equal to or greater than SignerQuoram. So let's see what it outputs. So malformed weight must be a positive value as expected. So let's alter this to 4 from 3. Let's make it 1. So total signer weight is 1, 2 and 3. As you can see, but the SignerQuoram is 4, which clearly violates the rule. You cannot meet the SignerQuoram, so it should throw error and not allow you to set this signer list. As you can see, quorum is unreachable. So always SignerQuoram should be greater than 0 and must be equal or less than the combined individual signer weights. So in this case, the signer weight is 1, 2, 3. Which is equal to SignerQuoram, so it clearly is valid. So transaction was successful. This sets our signer list for the master account. Let me comment out the whole thing here and just check the account information and account objects, etc. Just for confirmation purpose. So I'll output the account data here of that of the master account. So let's observe a couple of things here which we observed at the beginning of this video. That is, the flag is still 0, which means there are no flags. The owner count is 1 now. Previously it was 0. Once we set the signer list, the owner count increments by 1. That's interesting. Now let's check account_objects command. It must have signer list object in it. Let's check that. Let's even see the signers list in a nice way, in a formatted manner. Okay. Interestingly, we have a flag here. Let's check what it is in the next few seconds. So ledger entry type is signer list. We have the entire, this is important, signer ledger entry type is signer list. We have the entire signer entries. SignerQuoram is 3. And this is interesting, signer list ID. So this signer list ID field currently always has a value of 0. But in future, with some amendment, if multiple signer lists are allowed, then we can make use of this signer list ID. Very futuristic, right? So that is what it is meant for, which is not being used now. It is always 0 as of now. So now let's make use of this package, flag names, and see what information this flags field has. Let me comment this and output the result once again to fetch the fields. Let me fetch this field directly. So flag names, we have seen this extensively throughout this course, so I think we need not explain this once again. So as first parameter, it takes the ledger entry type, and as second parameter, it takes the actual flags and outputs its names. And then, as we know, account objects field has multiple objects. This is the first object, so let's just input its position, which is at 0. Okay, let's check the output now. So let's scroll down. So the flag it has is one owner count. That's interesting. So let's go to the documentation and see what purpose it serves. We need to go to ledger entry object, and here you have it. You can read it. It just means that with this flag, the owner count just increments by 1 irrespective of the number of signers the signer list has, effective after multi-sign reserve amendment. Okay. Now let's disable the master key of this master account, because we just want to have one method of signing the transaction, which is multi-signing, and this account doesn't have a regular key. It has one more method of signing, which is using master key. Now let's just disable that, so that we have only one method of signing the transaction, which is using multi-signing. We have a separate video on how to disable the master account. You can just go and watch it. I'll quickly write the payload and sign the transaction. The transaction type is account set. The account field has the master account's R address, of which you need to disable the master key, sequence number of the master account, and this is important, set flag. I'll just take a constant, assign it an integer value of 4, which means it has to disable the master key of this account. Let me sign it using the master account. And always remember, you can only disable the master key using the master account, and you can't use multi-signing method to disable the master key of an account. But then the reverse is possible. You can re-enable the master key using multi-signing or using regular key. Okay, now this disables the master key of this master account. Let's check that. So I'm running this account info command on master account, and as you can see, it has a flag which reads disable master, which means its master key has been disabled now. Okay, so in the next video, let's see how we can make some transactions using multi-signing.